Eric Ries and Jeremy Howard are building the Bell Labs of AI in Answer.ai, a company at the forefront of building smaller, cheaper, more affordable models, as well as applications in legal and education. We had a really interesting conversation on unsupervised learning that hit on what applying the lean startup process to AI looks like, when AI companies should think about moats, where the opportunities are in legal and education, AI safety, and more. I think folks are really going to enjoy this one, and stay tuned for Jordan and my debrief at the end. Well, Eric and Jeremy, incredibly excited to have you both on the podcast. We've been looking forward to this one for a while.
Thanks for having us.
Yeah. Eric, I feel like, it's one of the great joys of this job to get to talk to the author of a book that I feel like has defined a lot of how many of us in tech think about startups and building kind of, in innovating within larger enterprises. And I'm one thing I'm taken by is I feel like a lot of the lessons that you kind of put forth in the lean startup, it feels like we're seeing some different things sometimes in the AI world. We're seeing some big rounds, a lot being spent on models and compute long before anything touches the market. Curious, just your high level take on that, and whether there should be different lessons here, or whether the same thing applies in this industry.
Well, thanks for the kind words. And yes, it is a bit of a Back to the Future feeling. It's true in the startups. You're seeing it across the entire industry. You're seeing it in corporates who are trying to use AI. You see it in people trying to build products out of foundation models. And I think partly it's an artifact of the fact that AI makes just such unbelievably good demos. It's just, they're so magical. And so it's really easy to convince yourself that you're the exception and you don't need to test it with customers because the thing is self-evidently cool. So, you're just looking at it, look what it can do. And yet, I think, the same principles, at least at a deep level, the same principles are always true. That is, you can't know in advance what customers are going to want. And people will hear that, they're like, well, but customers don't know what they want either. And it's like, that's true. We're not saying that you're going to, it's like saying someone is like, I'm going to do chemistry. You're saying, oh, I can't do chemistry because I can't ask the electrons what they want. It's like, no, we can experiment. We can go discover what people want through their revealed actions. And I think the other thing that's making it especially difficult is people have taken the SaaS stack and just copy pasted it to AI. I mean, they basically just crossed out the labels with crayon and wrote in new labels, assuming that everything's going to be the same.
Right. That's like .com to .ai, right?
I mean, it couldn't be more transparent. Look, a lot of people raising a lot of money doing that. So far be it from me ever to criticize something that helps entrepreneurs raise money. That's, always good. But I think one of the problems with that is you have a lot of companies that have pushed the product market fit question to a different layer of the supposed stack. You think about all the AI companies that just make an API. They're seeing, some of them, tremendous usage of that API, and they're just assuming that their customers are going to be able to find product market fit with their customers. And if you follow that value chain, in many cases, it's not even 2 layers deep. It could be 2, 3, 4 layers deep between the model and the end product. And the issue there is that if anything is different about this stack, if it's not assembled the same way, there's going to be a lot of carnage in applications that are set up that way. And I've always been an advocate for wherever you are in the supposed stack to really understand who the end customer is and what they want, to make sure that you're part of creating something that can achieve product market fit. So I think that's not any different. But a lot of the tactics are going to look different. I mean, software development and model development are similar but not the same. The economics of AI are completely different than what we saw in software. And frankly, I'm drawing a lot more on the lessons I learned doing physical manufacturing and deep sea oil drilling and nuclear combined cycle power plants and nuclear plants, like things that had real infrastructure and operating cost and also market risk. It's actually you're amplifying the risk, not reducing it, by bringing in all this computational cost. So I think it's a really interesting time to be applying those principles. And I think it is important to be open-minded about what has to change and what is the same. But I think the core idea that, as Peter Drucker said, that a business is an entity that exists to create a customer. That's no different now than it was then. And the agents, the AI agents are not the customer. Human beings, you say metrics are people too. That's all they are. It's just human beings doing something. So if you're disconnected from that, it's very easy to go astray.
Yeah, no, I mean, it makes a lot of sense. And I feel like on the flip side, there's been, and it's funny, we had Arvin from Perplexity on the podcast. And I think one thing he talked about is a lot of people feel like they're paralyzed into action because of this idea of a priori, like, do we have moats? And, is there defensibility here? And a lot of people are maybe even looking at things where they're like, actually, this could provide value to an end customer, but like, is this defensible? And, I think different opinions on like, should you jump in from the start if you're not sure on that? Arvin's like, look, you have to build something that customers want, and then you have to earn the right to actually think about like, do you have a moat or not? Curious, like your take on that, because I think a lot of people are there seem to be a lot of things customers want, and then a lot of people intellectually thinking about if they have a business model around it.
It reminds me of the old parable of picking up dimes in front of a steamroller. So you have these like mega platforms with tremendous power, and they're so big just by definition how expensive they are, how many things. Think about all the different things that OpenAI could be building. So although in theory, anything you do, they could just nuke you from orbit by deciding to do it too. In practice, they're pretty fast for a giant behemoth, but there's only so many things they can do at once. They have to be focused. And so the vast majority of things they're not going to get around to doing, right now. And so the old lesson is that you can, if you're fast enough, you can jump into the street, grab the dime, jump out of the street. And if you're really smart, you can do that over and over again, picking up these use cases one after the other. And the only downside to that strategy is that if you trip and fall even one time, then you get totally flattened. And that's like, in tech, we used to talk about that all the time back when we had bona fide platform wars, Mac versus PC, Intel versus, now we're into x86 versus ARM. But, if you go back to Motorola versus Intel, and we've been through a lot of these over the years, different compiler platforms. Obviously social networks was quite violent. Android, iOS wasn't actually that much of a hardcore platform war because Google never really had their heart in it. But anyway, we've been through this before, but I feel like it's been a little while, and so people have kind of forgotten that a huge part of building startups, in the tech industry, used to be having some sense of industry analysis and understanding that the strategic options and stuff like that. But all that being said, it's so much easier to talk yourself out of doing anything than it is to, put yourself in a position where you're able to pivot. I'm kind of with Arvind on this one, where, yes, it's not that analysis is not useful. Of course, we want people to do analysis. And look, there are plenty of startups where you're like, man, even if it works out, there's no economics here. Even if it works out, there's no impact. And I even meet startups where I'm like, even if that works out, it's pure exploitation. And so you might make money from it, but you're not going to sleep well at night. So there's plenty of things you can rule out. But if you have something that you passionately believe in, if you're not sure how to analyze it, or even if someone who sounds really smart tells you that you're doomed, I don't feel like that's a good reason not to do it. But I do think the humility does have very concrete company building lessons you have to take. In particular, you have to build in such a way that you can do rapid iteration and you are able to pivot. You have to be alert to the possibility that your assumptions could be wrong. And that's, people, I think, sometimes think, like, okay, because I've given up on analysis, therefore I don't have to iterate. And it's actually the opposite. No, you need it even more because you're not completely sure of what's going to happen. And with the level of uncertainty that we're facing with AI, I mean, anyone who thinks they know even just what are the capabilities of models going to be, in a few years, or what are consumers going to want? How is it going to affect society? People are making very confident pronouncements left and right about this. But I don't see how anyone can attach like real serious confidence that they're correct in those things. You're much better off preparing yourself for a range of possible futures. And that definitely, I think, is a strong argument for having a strong vision, but being prepared to pivot.
Yeah, I mean, I think just given the pace at which things change, it feels like the rapid iteration and kind of ability to quickly adapt and get feedback has never been more important, right? Just given how quickly things move.
I mean, what do people expect me to say? But yeah, obviously, I think so. But I mean, I really do think so. And I feel like we're already starting to see the first wave of companies who didn't do that run into serious trouble. So we I feel like we're speed running the usual industry hype cycle, where usually it takes a couple of years before people start writing the article about how you don't need lean startup anymore. And then the things, then they write it about Quibi or something. And it's like, it's always the companies they write it about that then later have a monumental crash. So we've skipped that step because we're going right to the crash. That's progress of a sort, I think.
So we'll definitely come back to the lean startup in a second here, but I wanted to turn our attention to you, Jeremy. Obviously, you started fast.ai with the intent of teaching deep learning to folks. And I wanted to get your thoughts on, if you are an LLM curious person today, what do you think is the best way to get caught up?
I mean, fast.ai and Answer.ai are not so different. The goal of both of them is the same. So Answer.ai is a public benefit corporation. Its stated public benefit is to maximize the public benefit of AI for as many people as possible, which was exactly what fast.ai was created to do as well. I think the difference is that language in particular is such a powerful modality, and we've now started to unlock that modality with computers, that it deserves a particular focus. Also it's when my wife Rachel and I started fast.ai, it was so speculative. This was, we were the first broad online deep learning course for non-PhDs. The idea that people who don't have a PhD could learn and use this tool was generally considered pretty ludicrous, and pretty naive. And the idea that you could write software that made it, so that you could create applications in a few lines of code was also considered naive and ludicrous. Now that we've gone quite a few years down that track, and it turns out that these things actually worked out pretty well, I think, apart from anything else, it's just time to invest a bit more into this mission. So, now we've got, VC and angel money behind us. We've got a team of people behind us. And of course, we've got Eric working on this mission with us as well. And so, it feels like we're really kind of setting ourselves up for success here in terms of this mission of creating widely applicable, societally beneficial applications of artificial intelligence.
So that's a great segue into Answer.ai. Obviously you two together have just incredibly credentialed backgrounds and could really work on anything you want to. And so why did you decide to really go after this? And how did the idea come about in the first place?
Well, Eric and I had been talking about it for years, really. Whenever we chatted, we were always just chatting about AI and about how many opportunities it created. And I was kind of asking for his advice. One of the pieces of advice I asked Eric about was fast.ai was hamstrung by the fact that everything that we created, all of our research, all of our courses, all of our software required a strong coding background to take advantage of any of those things. And for something that's attempting to make AI as accessible as possible, you're restricting yourself to less than 1% of the world's population by doing that. It seemed like maybe there's a huge opportunity to actually make it way more accessible, by taking advantage of natural language and other natural modalities, vision, and so forth. So, one piece is kind of saying, well, how do we take advantage of this? And another, so that's the opportunity. And then there was this kind of threat of also it seems like the thing that fast.ai was created to counter, which was Rachel and my concern that AI will lead to massive amounts of centralization of power and as a result decrease opportunities for most people. That centralization seemed to be accelerating, in that sense, I felt like fast.ai's mission was failing. So that's really where it started, I guess. At least, Eric, that's my memory of it. Was how do we try to capture this opportunity whilst trying
Eric,
to deal with
do you agree
threat?
with any of that, or do you have a completely different memory of where it all began?
Yeah, let's talk about. We were in Barbados doing I think that's definitely right. I mean, I think to call fast.ai a failure is frankly ridiculous. So I don't agree with that. But I think. And I think Answer.ai is made possible by the tremendous goodwill that Jeremy and Rachel have built up over so many years, helping so many people enter the field with not just educational resources, but really a real sense of values and ethics about how this technology could and should be developed.
One of the things we both struggled with was thinking about this is unlike fast.ai, which was entirely funded by Rachel and my personal bank account. This was something we felt was worth investing more money into. And we didn't know who the hell would fund such a thing because it's not a normal startup. Answer.ai is a for-profit R&D lab. So questions like, what exactly is the proprietary part of your technology? What exactly is your product market fit? Who exactly is your market? What's your 5-year financial plan? We don't have any of those things. Like, the nature of an R&D lab is that you do the R and then you get the D, and
I mean, it's interesting. If you told me that the author of the Lean Startup was starting an R&D lab, I would have thought that those two were like almost antithetical to each other in some way.
No, I listen. That's a very common misconception. And I've actually worked in like old school industrial R&D labs. Like, we use that as a metaphor here. I'm talking about people that are doing actual research on heavy industry. And part of the problem, both in academia and in industry, is we have, over the course of the past century, had this tremendous drift. It's natural, I think, as a result of specialization, but it's also a bit of indictment of the way our capital markets work and time horizons. We have had this hyper-specialization where the R and the D have become so separated. We actually now do really large amounts of research, completely untethered from practical applications, in ways that Thomas Edison would find bizarre. And so some people look at that and they say, okay, the right solution to that is to have a specialized research function and a specialized development function, and you run Lean Startup in the development function, and you tightly integrate them together, and you have to. But Jeremy and I both happen to have the idiosyncratic belief that the very best research is done only when the researcher, it's him or herself, is coupled to the application. And so it's not to say that this is the only kind of research that can or should be done. Of course, there are many different approaches, but I think as a society, we're way underinvested in this style where the iteration loop, goes from the customer all the way through into the scientific inquiry and back out again. And I could tell you funny story after funny story of times when I've done this, doing Lean Startup transformations in a corporate setting, in an industrial setting, where the thing that the researchers are like practically trying to win a Nobel Prize solving is not of value to the customer. So it's like, first we have to win a Nobel Prize so that we can then, make a material science breakthrough so that, I remember a very funny example of building data centers, technology for data centers. And, they were really focused on the energy efficiency of the thing and, what its operating costs would look like. They had all these like extremely difficult performance optimizations that the scientists were working to figure out how to do. And I'm not being facetious about Nobel Prize level. It was required like fundamental physics breakthroughs to achieve. And the first time we made them take an MVP of the thing to the data center builder, we learned the very basic facts that, first of all, the person building the data center doesn't operate it. So they definitely don't care. And the first question they asked was a question that no one was asking in the lab, which was, well, what's the footprint? How big is the thing? Yeah. They're like, oh, to make it energy efficient, we only have to increase its size by 300%. So that should be a really good trade. But if you think about it from the point of view of a data center builder, they want to know how many racks they can squeeze in. And you're going to take how many racks away from me in order to save money by someone else? Why don't? I mean, it was just like such a classic thing where they're working so hard on the thing that doesn't matter to the customer. And when we bring that into alignment, once we brought that fact back into the lab, it took one of the junior PhD, level research like 5 seconds to be like, oh, well, if you're looking for a different set of trade-offs, then the scientific problem is really different. Let's go have this other breakthrough. And then we're off to the races. And so that's kind of a trivial, crude example. We're just doing it one time. But if you do that in a continuous loop, then tremendous breakthroughs are possible.
So coming back to the source of this part of the discussion, given that this kind of R&D, for-profit R&D lab hasn't appeared in the world since the early days of electricity, we weren't sure who the hell would fund it. And we had a lot of good luck because actually,
I think it was from one of your podcast appearances.
The last time I did a podcast interview.
Yeah, exactly. I feel like we're going to have to give you a term sheet after this.
And I reached out to one of the interviewers, Alessio, afterwards and said, like, could I get you some advice? Because it seems like you guys talk to everybody. And and I said to him, like, we're thinking about doing this like R&D lab thing, but I don't know, like, what kind of investors, would give money to such a thing? He said, oh, we can give you a term sheet tomorrow. So, there was a lot of like, I know how much luck there was now because, since that time, we also decided to bring some angels in. And literally, I think every like AI insider I reached out to, maybe all but one, who I invited, would you like to invest in this? Said yes. So, amongst that group, everybody wanted in. But then we've had a few people reach out and be like, oh, Jeremy and Eric are doing something like, traditional investors. We definitely want in. Like, please talk to us. And then when we talk to them, they're like, so what is your proprietary technology exactly? Okay, and like, who is your market? And whereabouts in the SaaS stack are you? And it's just like, wow.
All right,
okay.
I'll erase we had all those questions teed up for this episode, but I'll just get rid of them so we're not mercilessly mocked.
The key insight I think that maybe some of your listeners would benefit from is the idea of a stack to begin with. The idea that there's abstraction layers. This goes back to right, the layers of the IP stack and the way that the internet technologies work, and the stack that people developed around semiconductors and how that relates to the development of software. Like that, those are very useful abstraction boundaries when you understand enough about the thing in question to know how the layers interact. And even then, the reason we prize full stack engineers so much is there are these times when you have to break the abstraction boundary in order to get the thing that you want, because you're trying to achieve something that only by integrating across layers or doing something unusual can you achieve. When you have a nascent field like this, the reason why as you said, the development helps the research, but the reverse version of it is also very valuable, because I think prematurely deciding what the abstraction boundaries are just leaves a lot of opportunities out of your consideration set. And we've only been at this a few months. We've already had numerous situations where someone who really deeply understands the technology will be able to say, your assumption about XYZ is just not true.
What's an example of that's happened for you guys?
I think a great example is, lots of discussions about agents. So there are places that agents are well connected with the capabilities of language models, and there are places where they aren't. Most of the places, they're not. But you only understand those places if you have a deep understanding of the underlying theory of the so-called linearized subgraph matching operations on which LLMs work. When you deeply understand those mathematical foundations, you realize that any kind of agent which requires kind of novel planning, and I don't mean novel in some kind of like Nobel Prize level novel, but just like a planning sequence which isn't almost exactly in the training data, it won't be able to do it. Anything which is largely various mixes and matches of stuff that you've seen in the training data, it will be amazingly good at. So, agents which kind of help you answer your emails, or label them or whatever, or add some CSS to your HTML, or, iteratively debug common Python problems are going to be great. Whereas agents that attempt to, independently create a research breakthrough, or the thing I come across all the time is I because I'm a researcher, a lot of my code is creating algorithms. They're not rocket science. Like often they're just 4 or 5 lines of code, and I've never, ever had a language model help me at all in creating any of those algorithms, because by definition, they're not in the training data. If they were, like I'm pretty good at algorithms, so I wouldn't be asking the language model for help that everybody already knows about. So like this is an area where I think like understanding, the low-level research really changes, the type of development that we try to do.
So interesting. I mean, obviously you guys started, and I think you kind of recently released some stuff around, an efficient fine-tuning of Llama 3. I'm curious, like, how did that come about? Can you talk a bit about what you found and kind of the implications of that for builders?
Yeah, definitely. So this is such a great example of so many of our values and premises here. So in short, the Llama 3 fine-tuning breakthrough was done by one guy. His name's Kerem. He lives in Turkey, and he was like the best master's student I ever had. And then like, okay, how did the management occur or whatever, which we decided to resource that project? It didn't. We don't have managers. I'm actually not a manager. in our company, and I don't do any management when nobody does. He just decided to. He decided it would be a good idea. And he started it and he started doing it. And along the way, some of the team were like, this is really cool. Let's find out how we can help Kerem. And they helped, here and there. But then why were we working in this space in the first place? Well, we were working in this space in the first place because we operate as an R&D lab, again, in the same way that Edison's lab did. It's what, there's a great historian of these labs. His name's Eric Gilliam. And Eric did an analysis actually of Answer.ai. And
yeah, we'll link to that piece, a really, really good piece.
Yeah, it's a great piece. And he describes this as a long leash with narrow fences. So Eric and I created the narrow fences, so from early on, we tried to figure out what's the research thesis here? What's the idea? We thought, well, there's a real overinvestment in training foundation models from scratch. There's a real overinvestment on doing things on gold-plated, super expensive hardware. There's a real underinvestment on the real world, which is resource constrained. And so we brought on people that care about efficiency, that care about, doing things at a reasonable cost, and they're actually often folks who therefore come from backgrounds where they had resource constraints themselves. So they deeply empathize with these things. Yeah, so we've all been working as a team on trying to think how do we bring the price down? And it's really interesting because when I went and visited one of the big labs in the Bay Area and had a chat with their kind of main Gen AI team, and they were saying to me, what are you doing? And I was trying to explain this. And I remember one of them looked at me and said, so what's this for? Sounds like it just brings the cost down. Yeah, that's all, when I say, let's make it more accessible, that's the definition. If we can bring the cost down by 10x, which I think we can, then lots more people can use it. But to them in these big labs, the idea of it's just the same thing, but cheaper is tedious, whereas to us, it's it's what we're trying to do.
Yeah. The other thing I'll say is that there's these moments in industrial evolution where a difference in degree becomes a difference in kind. So people are okay, well, so what if you make the inference cost cheaper? That just improves margins, but it doesn't just improve margins. This is the first time the software industry has been dealing with actual supply chain constraints, in a long time. It's about physical installation and power access and how much HBM memory can be manufactured in the whole world at any given time. So first of all, it makes things possible that wouldn't otherwise be possible. But I also think we're going to see a lot of uses. A lot of the things people really want from Gen AI are not possible now just because of the cost. So, when you can imagine a future reality when it's so cheap to fine tune a model that you can do it continuously. So rather than actually viewing the model as pre-trained and then fine-tuned and then deploy, we basically only deploy amnesiac models today that can't remember anything about what they did. It's this memento all the time. So they're writing down on the context window a scrap of paper to try to remember who is this person I'm talking to, and they easily.
Wow, I've never heard the memento comparison, but that's really? A great one.
Yeah, well. Seems very obvious to me. I better write that down on my skin before I forget.
Yeah, exactly.
It's not going to be that long before that's going to that's just fundamentally not going to work for so many use cases where you want the hyper personalization and context and memory of an actual artificial intelligence. So if it was cheap enough that you could continuously fine tune, we call it continuous pre-training of an individual agent, on an individual inexpensive virtual machine, then that opens up a whole range of use cases where you might do that. Where you actually might be willing to have dedicated resources for each customer or for each thing that needs that level of customization. And so I think it's very easy to dismiss cost, in the physical world, what they call manufacturability. So many of the applications of electricity didn't require some kind of super genius to figure out what you would want to do with it. But making it practical was extremely difficult and required hundreds of thousands of individual experiments painstakingly done, by a relatively small group of people. And a common criticism of Edison was that he was hyper obsessed with that stuff and not, didn't have the prestige that you would have doing real science. But he didn't care. He understood what he was trying to accomplish and was just willing to knock down the obstacles to get from here to there. And so we need a little bit of that, I think, in this world with AI. We have too many splashy demos and not enough deployed products. And I think a lot of it has to do with the ergonomics of the technology itself, its deployability, the cost, just the usability of it. And then, there's a few, there's UX breakthroughs that are required. There's real creativity required too, but let's not neglect the need for real infrastructure. And again, we haven't had that in tech in a while.
There's two kinds of inventions, I think, right? There's the light bulb kind, which, as you say, Eric, was basically like, electricity, we can store and distribute energy. Energy can be used to make things glow. Yeah, obviously, let's figure out how to create a light bulb. And Edison's invention factory were good at those. But they were also good at the other type, which is like, okay, we could use that stored energy to rotate a disk. We could put little divots in the disk. We could have those little divots use a magnet convert to movements of like a flat thing, and that could then create sound waves, and we could use that, we'll call that a phonograph. We can use that to play music. Yeah. Or we could use the energy to compress gas, and when gas is compressed, it makes things cooler, and we could use that to create a kind of refrigerator. Like, those are clever. Like, those are a different kind of invention, which is like a big step. Now, interestingly, the thing that lab had that allowed them to create those things was getting all these, people together, not heaps of them, but these people who live and breathe electricity all the time. They're not necessarily professors of physics, although some were. Some were boilermakers or, engineers or whatever, and just have them making lots of stuff so that, Edison always said, that he felt that their group of people had this great gut feeling of what this technology could do. And that there were very often situations where fancy physicists would write papers about things electricity, provably can't do. And they'd be like, yeah, but obviously it can. Obviously it can. And this is the kind of like AI factory we want, one where there's this group of people that just has a really good intuition for like what kind of stuff we can make, what kind of stuff doesn't make sense to make. And it doesn't all have to be based on theory. Some of it will be of the light bulb kind, the stuff we've already released is definitely of the light bulb kind. Everybody, I think, understood that if you combine quantization and distributed computing, you could dramatically improve, the accessibility of fine tuning and drop the price. And just doing it was really difficult. But, I hope we'll also be successfully able to create the phonograph style inventions by creating this group of passionate, enthusiastic individuals. So one of the things we do, for example, is we give everybody in the team a $500 a month credit card to buy any AI stuff they come across and use the hell out of it. Because
what have been the most common purchases so far?
It's just the normal stuff like coding helpers, Copilot, and everybody loves Perplexity and all that kind of thing. But the idea is like there's a lot of overlap in the Venn diagram of what people choose to use, but there's also a lot of differences, and it's in those differences that we get this kind of like these great conversations where people say like, oh well, if you've ever used Cohere's Command R plus model, then you'll realize that their particular approach to retrieval has these particular benefits without having those particular drawbacks. And, we can see, and it's like, you've got to be, really deeply invested in the ecosystem and the products as well as the research to appreciate these opportunities and constraints, I think.
So I know we've talked a little bit about this already, but I'd love to go a little bit deeper and understand if there are other areas or ideas that you're going really deep into right now, or if there are any that you've had that light bulb moment with that you mentioned.
There are broad areas where this new ability to compute with language and to interact with a computer with language is such an obvious fit. So 2 particular examples we're excited about, and this is not at all controversial, is the law and education. These are both like pretty heavily language-based things. One of the lawyers we works with describes a law firm as just a very large language model. You feed in text and you get out text. Also, they're places where there's huge opportunities to help society a lot, right? So let me take both of them in turn. The law is used a horrifying amount as a weapon by wealthy people and organizations to stop less wealthy people and organizations from doing things that they really ought to have every right to do. And every time that happens, that's a grave injustice. But it's something that as a society on the whole, we just kind of all accept now. It's like, oh yeah, you can't win that battle. It's like, well, what the hell? What was the law there in the first place for? If like not to protect you in that exact situation from that exact thing happening. If we can, again, as a price thing, if we can bring down the cost of high quality legal advice, that's just damn good for the world. That means that the law can be used by a weapon less often, by less people. And also, particularly in countries like the US, the law is often used for gatekeeping. So, you can't enter this regulated market unless you go through all these loopholes. And, this has always been something I'm passionate about, is like if somebody has an idea for a thing they want to bring into the world, I want to help knock down all the things that would stop them from doing that. I'm a homeschooling dad. I have spent many, many hundreds of hours, probably thousands of hours, researching the academic literature of education and listening to teacher interviews and, of course, teaching my own child. There are so many opportunities to just improve education so that more people can do the things in their lives that they have in their head, that they can build the things they want to build, that they can be the people they want to be. And currently, not nearly enough people have that opportunity. Teachers are amazing, but they have to work within this very constrained environment where they have a whole bunch of kids that have to go through the same path at the same time in the same way with pretty limited ability to customize. So I've seen for my own child how delighted she is when we remove that. If we can help, more people access the law and more people access education, both of which are really heavily language in, language out things, that would be amazing.
Jeremy, I'd love to discuss a piece you published yesterday, actually, around the bill SB 1047, which is placing, limitations and regulatory checks around training foundation models. We'd love to hear your thoughts on that and why you're concerned about it.
Let me start by saying, this particular law is a proposed Californian state law. I think, it's clearly created with the best of intents, which is, and it has some good features. But, I want to particularly talk about one part, which I don't think is a good feature, which is a part which attempts to ensure the safety of AI models, which sounds like a good idea. We don't want unsafe anything. We don't want unsafe planes or cars or toothpastes. So why would we want unsafe models? So as it happens, about a year ago, I spent many, many months studying this exact question, because at that time, a group called Governance AI, along with groups like OpenAI, were involved in releasing a new framework for creating laws of exactly that kind. And they were kind enough to provide a draft copy of it to me, and I agreed to kind of red team it, basically. And I interviewed over 70 experts across the spectrum of all the kind of fields that touch on this question of, is such a policy a good idea? And it turns out counterintuitively that not only is it likely such a policy would be ineffective, but in fact it would be likely to cause the opposite result. It would actually be likely to create a less safe situation. And there's a number of reasons for that, but in the end, the key reason is a model, the model itself, you can't ensure anything about it because it's just the most purely kind of dual-use technology, like a pen or a piece of paper or the vote or education or a calculator or the internet. Which is to say, if I make a model, right, and I can test the hell out of it and be like, oh, it never creates bioweapon recipes or whatever, but then you can take it and fine-tune it, or prompt it or whatever to do whatever the hell you like. I can't stop you from doing that any more than if, you could buy a calculator from me and use it to do calculations necessary to create, a nuclear bomb. Or you could buy a piece of paper from me and use it to write down a death threat. I can't ensure that you don't do those things with my dual-use technology. So what happens in practice? So if you put in such a regulation, what has to happen in practice is that you never get the pen and paper, you never get the calculator, you never get the model. All you get is some kind of layer on top of it. So it's like, oh, we'll provide a service where we will write things down for you, but you can't have a pen and paper, or you don't get the vote, but you can advise us on who you would like to run the country or whatever. You kind of like put these layers in between to ensure that nobody could ever do anything bad. You don't give them the power at all. That's the difference between, for example, ChatGPT, which is a great product, and I like it and I use it, right? But that's a product where you're not using a model, you're using a layer on top of that, which you kind of can ensure the safety of, right? Because I don't have access to the model itself, versus like Llama 3, where I can actually download the model and use it for whatever I like. So if you create a situation,
a really efficient fine tune, right?
Yeah.
So that happens to be your purpose.
So if you say you're not allowed to release a model unless you can ensure the safety of it, then in practice it means you can't release models. You can only release products on top of them. But models in their raw form are much more powerful, because you can fine-tune them, you can study their weights, you can, look at their gradients and activations, you can really control them, you can do clever caching with them, So anybody who has access to the underlying model, has huge advantages over somebody who doesn't. So therefore, as soon as you say like, well, nobody's allowed to release such a model, which is what happens in practice if you say you have to ensure the safety of it, you've now made the models themselves an extremely rivalrous good, a jealously guarded secret only available to big states and big companies, something you fight over, something you compete with, and so now what have you done? You've taken something which is this dual-use technology, like a piece of paper or like a calculator, which lots of people could have been using to like improve cybersecurity or improving, vaccines or, doing all these things that are defensive in nature. And in fact, instead you've made it an extremely rivalrous good that a small number of super rich organizations compete for access to, and have to race to make bigger ones and better ones. And nobody has the ability to, there's no transparency, so nobody can be studying how they work and what they can and can't do and so forth. So that's basically the issue. It's exactly the kind of legislation that my analysis last year showed can't work. And at any time you try to ensure the safety of a dual-use technology, like a model, then by definition, you create a highly competitive space, massive centralization of power, and reduced transparency.
Super interesting. And I guess, going back to the conversation we were having earlier, Eric, I'd be curious, like, we're talking obviously about, the kind of foundation model companies and how taking all this massive fundraising rounds and then going in a lab and building a model for a year before getting it out there is maybe not as not the classic lean startup approach. I'm wondering, like, if you were running one of these foundation model companies, like, what would you do differently?
Well, it's actually not the foundation model labs that I have really the issue with, because their mission is to try and discover whether AGI is possible to build. And
that's fair.
to whatever degree they commercialize anything is just to show the progress necessary to raise the money, to do the research, to do the thing. And I'm glad there's people pushing the frontier. There's just an unbelievable reservoir of applications that don't require AGI to unlock that we're not building and we're not focused on, because it's really the fundraising gravity has pushed so many entrepreneurs away from utility and into science fiction and speculative stuff. And so I think we're missing out on a lot of actual practical uses. And in fact, one of the investors into Answer.ai is a major AI safety advocate, and one of the things that I think was really a key realization for him was that if we live in a world where the only models available are frontier models, and we can debate whether they're at AGI now or they're going to get to AGI. I don't want to get into all that, but just whatever the closest thing to AGI that's available is really the main thing that people are using. Then you're actually, when you deploy those models, you connect them up to real world systems. You're just really asking for a lot of unsafe things to happen that, in theory, could have been done with smaller models that are properly fine tuned and are basically safer by definition. And some people, of course, think that there is no safety worry in the frontier. I don't want to get it. It's a very controversial point, maybe many different views about it. But my point is that everyone can agree that there are ways to build a huge class of valuable applications that are intrinsically safe. And if nobody provides those options, then people will default to doing the unsafe thing. And so we don't want to live in a world where there's no open source, where there's no open source research, where there's no ability to fine tune, where there's no ability to build these cool models. Build applications out of small models. I don't think that actually advances the cause of safety. But
interesting.
But all that said, having spent some time with the foundation labs and knowing the challenges they face, as they're getting bigger, some of them have become quite schizophrenic, where you have this like safety research AGI thing that was started out to be, but then you're building this unbelievable commercial apparatus. And in a lot of cases, the commercial people have only the faintest idea what the safety agenda is, or in some cases, I think basically don't care, are just there to make number go up. And I think that's actually where it can get quite dangerous, because now you have the rival tensions within the organization that can rip it apart, and you can lose the coherence and the alignment that's needed to keep the company together. So certainly one thing that I would do if I was in those labs would be to try to reestablish the connection between the research and the customer, as we've been talking about. I don't think that's very realistic. I think they're not that interested in doing that. But if they viewed it as their responsibility to see that their customers were successful in the deployment of the technology and they could, I would take a point of view about the applications you want to affirmatively see be able to be built, and go, take an old page out of the Toyota production system playbook and go and see for yourself, go sit with the customer and really make it your responsibility to see that they succeed. I bet they would learn a ton from doing that. I hope more of them embrace that.
Super interesting. Well, this has been a fascinating conversation. We always like to end our interviews with a quick fire round where we get your quick takes on a few common questions we ask our guests. And so maybe to start, would love, I guess for each of you, one thing that's overhyped today in AI and one thing that's underhyped.
Overhyped agents, underhyped resource efficiency.
Why do you think agents are overhyped?
This is the reason I mentioned earlier. The things that most people are trying to do with them are not compatible with the mathematical foundations of the models.
Next up is, what AI startup outside of your own are you most excited about right now?
There's so many to choose from that are so interesting.
Yeah, where are you putting your $500 budget toward?
Yeah, totally. Listen, I'm trying to buy. I want to buy more AI products. Please, everyone listening, please sell me some AI products. I'm dying to buy them.
Everyone at Answer got $500 to put them, so you can get started.
I really do. I actually really. It just feels so lame to say that I really like Perplexity, but because everybody does. I think we haven't talked. We've been about cost as a degree in kind change, but so is speed, and the speed at which it operates is really unbelievable. I actually would give you a more original answer than that, though. You got Jeremy. You answer, and I'll keep thinking about it.
I'll go with Grok with a Q, for the same reason. They're fast and taking a different approach, and it's an approach which I think is, again, foundationally sound. I don't think they count as a startup anymore, but I just want to say also Meta are the most important organization for AI right now.
I guess what's one breakthrough? Obviously there's lots of things that are talked about that might happen in GPT-5 and beyond. You obviously feels like you have your kind of current beliefs on the capabilities of these models. What's one breakthrough that would change your mind on some of this stuff?
I think there's two. The first big issue right now is just the massive energy requirements, which is just putting a direct, economic or even physical obstacle as to what we can do. The models are already very good, but it just, there's just a lot of resources required. So a breakthrough in the amount of energy or other resource requirements would be huge. Even bigger would be a breakthrough in this kind of like planning and reasoning capability, something that goes past subgraph matching. So, in particular, Jan LeCun and his group have been working on these, they're called JIPA-based models for a while now. They are, quite a different approach. There are also other folks working on what are called diffusion models for text. Again, quite a different approach. The current approach, which is like, all right, pick a word. Okay, got it. Now pick your next word. Okay, got it. Now pick your next word. Like, that's literally how they work. It's called autoregressive.
Well, when you put it like that, it sounds less exciting.
I mean, they're very good at picking words, right? But the actual important word might be like in 50 words time, but if the previous 49 words didn't head you in the right direction, that's going to be a problem, So these other approaches like JEPA and diffusion might get us out of this autoregressive approach and allow us to move into a land where we're doing more than pattern matching. Although, it turns out pattern matching is way more powerful than I think a lot of people intuitively expected, but it has its limitations.
The most interesting thing to me about LLMs has been the change in my perception of what human intelligence is all about, and the fact that far more of human intelligence is obviously encoded in language and linguistic processing than we previously thought. And one of the wildest facts of the LLM revolution is that every weirdo postmodernist theory that has ever been cooked up in an English department anywhere, in a literature department anywhere in the world, every obscure theory, and they're all going to turn out to be empirically testable. Who would have thought? That's like totally wild. And the thing that I'm waiting for, like, I think that would really blow my mind, but I don't view it as like implausible, is that something in this someone will have a breakthrough and realize that the problem is not in our understanding of the scaling of LLMs. The problem is in our understanding of cognition itself. In human cognition, since we don't understand how it works, we've been trying to emulate it in this super brute force way. And the metaphor that I always keep coming back to is, you ever see one of those YouTube videos of someone who's built a calculator out of Minecraft blocks? And it's like, it's so amazing. You're like, wow, I can't believe that Minecraft blocks are a general purpose computer and they're Turing complete. You can compute anything you want. But like, it's basically the most brute force possible way you can think of to make a calculator, except what I'm about to describe to you. Imagine if I said, look, I'm not going to do that. I'm just going to try every possible combination of Minecraft blocks until one of them happens to be able to do calculator level computation. I would eventually find it if I throw enough GPUs at it, do enough math, it can be found. So like, is there something like that lurking in here where we're going to wake up one day and realize that we brute forced our way to an extremely, the most inefficient possible way of discovering some critical algorithm in cognition? And actually, if you could do it directly, then it would be a breakthrough. Now, people have been looking for that thing for a long time and haven't found it. So maybe this is the best we can do. But that would be the thing that would shake my beliefs quite a bit.
I'm sure a lot of folks will want to learn more about you both and Answers. Where's the best place for them to go to?
Answer.ai.
Easy.
How did you get Answer.ai? That's like a great domain. I feel like that must have been a competitive process.
No, I had it for ages.
Really?
I grabbed a bunch of .ai domains many, many years ago.
Nice.
I'm surprised you didn't just fund the company off that.
One of the ones I bought, but I actually sold, was emergent.ai. And emergent.ai for many years just had a single sentence on it, which was just AI is not emerged yet. But then somebody me. So.
It would be a scary day when you went to the site and that had changed. So
exactly, that's what it was there for. Yeah. That was my little canary. Yeah,
that's awesome. Well, seriously, thank you two so much. I feel like this has been a fascinating conversation. I'm sure folks will want to pull on a lot of threads, and it's obviously a privilege of our job to get folks like you on. So really appreciate the time.
Oh, thanks for saying so.
So that was an interesting conversation. What did you think, Jacob?
Yeah, I mean, talk about getting two legends on the podcast. Between Jeremy and Eric, I feel like we could have done 2 hours with one of them. So to get them both on is a real treat, and I feel like they have really interesting perspectives. I mean, Jeremy's such a polymath, right? He's obviously super detailed in AI regulation, and then he had founded a healthcare AI company before, and is super deep in obviously in the education space through his work at Fast.ai. I think, I'm sure it's a great personality to run a research lab because there's so many different directions that he can go in, which I think is what's so interesting.
Yeah, I mean, I think it's an interesting combination between him and Eric. A lot of the research labs we see are just hardcore AI people, and they go in to sort of solve AGI. But here you have Eric, who is all about customer facing and in learning about what the customer needs, and so it's an interesting marriage of the two.
And I love their idea that basically there's just so much more we can build today with today's capabilities. I mean, I think, their point that, yes, everyone is obsessed with what's the next frontier and, what's reasoning and planning and, agents that take action. But like just with the capabilities of the models we have today, if we make them cheaper and more accessible, there's so many applications waiting to be built. And I know we certainly feel that way. I feel like I keep saying 2024 feels like it's the year of applications.
Yep.
You're really starting to see folks that have built on top of models with GPT-4 like capabilities for a longer period of time, just in every vertical, discovering lots of really cool applications. And it's cool that they, legal and education are obviously two of the most interesting ones for them to be spending time on.
Yeah. What were your thoughts on the health comments as the health expert?
Healthcare is not for the faint of heart. I agree. And no, it's true. I mean, I think that I think so much of what Eric says really resonates on the lean startup side, where it's like, you don't want to build something and then bring it to someone and realize their incentives are warped to not even use that product. And I think that's a classic problem we've seen in some areas of tech. Healthcare, one of them, where I think a lot of the best entrepreneurs you see in the space really understand the end incentives of different folks in the ecosystem. And then, the challenge is, can you still build a mission-driven, impactful product that meets those, and fits into those incentives? But the magic really happens when you're able to do that. And so I think, I love their push to like, go have the conversations and talk to the end customers before you build the product, because I think that's going to just guarantee much more impact.
Yeah, no, I mean, I agree. And I think it's super interesting, their approach to more of the application side of things that we haven't really seen in a lot of the other research labs. The fact that they have 3 lawyers in-house working on the legal side of things, I think it's super interesting. And, to your point, legal and education are just 2 areas we're very interested in at Redpoint, but it's such a clear value prop where you can go in and talk to tons of customers and really dig into the pain point. It's very easy and clear to do that.
Yeah, no, totally. And I like this idea that law was just, language in, language out.
Yeah.
I think our job is probably analogous to that as well.
I would say so.
And so, yeah. But I think, certainly, I don't know, just really interesting, interesting approach to how they're tackling the space. It's certainly different. And I'd encourage folks, they had, there's a great piece that we'll link to of just the history of research labs and why they thought it was the right approach here. And it's definitely different, which I think is, it's cool to see, people take this transformative technology and then structure organizations in a ton of different ways around it. I mean, we're seeing all sorts of innovative things from the kind of nonprofit OpenAI board governance to this, and a lot of experiments being run about what the right way to use and responsibly use this technology.
Yeah. And I think, it wasn't on the application side, but I do think the conversation around the regulatory aspects of AI and just hearing Jeremy's perspective on how, the more we try to make it safe, the less safe it becomes, and really striking that balance. It's counterintuitive, but it's super interesting.
Totally. I know that's something we really, obviously we're huge proponents of open source. And I think, when you get something out there and get the most eyes on it, that's, when ironically it ends up being, the safest. And so I think that certainly makes a lot of sense. It was definitely a really fun one.
Yeah.
Got some other great guests coming up in a few weeks. So we'll look forward to seeing you then.